All right, so today we're going to take a look at these rational functions again and how to find our zeros. So again, our domain is where there's a 0 in the denominator. So if I say that can't be 0 there. 2x squared equals -4. Well, there's no number squared, so it never equals 0. So this is just all reals, or -infinity to +infinity. Now a 0. So let's think about something for a minute. 0 divided by any number is 0, but you can't take a number and divide it by 0. That does not exist. So for this to equal 0, it's when x squared plus 2x minus 8 equals 0. And you guys can see from here, right? We can probably factor this. Whoops, right there. So this factors into x plus 4, x minus 2 equals 0. So our zeros are at x equals 2 and x equals -4. So we're going to see something that happens though, right? Something called a hole. And a hole happens, right, when it looks like our graph might be there, but there's a number that can't exist. So for example, in this one, x minus 4 can't equal 0. So we know that x can't be 4. And if we factor the top here, we have x minus 4, x plus 3 over x minus 4. Well, when you look at this, this factor is the same, so we reduce out. So this just looks like x plus 3, which we know that's a line going up 1 over 1, up 1 over 1. So this is really just a line right here. But we know it doesn't exist at 4. And if something crosses out from the top and bottom, it's called a hole. And our hole is at x equals 4. And if we plug it into the simplified equation, 4 plus 3 is 7. That means it is at 4 and 7. So on our graph, we can denote that by putting a little open circle right there, that's a hole. And where are zeros? Well, we said this was a hole, so where does x plus 3 equal 0? So our hole is at -3. So zeros occur when n and they don't have any common factors, and the zeros occur when n of x equals 0, the numerator equals 0. So now we're going to take a look at how do we figure out where these vertical asymptotes occur. So the first thing we have to do is factor. And so this factors, take out a 4. Our bottom factors into x plus 5 and x minus 3. So our domain right now, we know it's all reals, but we could say x can't be -5 and x can't be 3. And we know there's no holes because nothing cancels out. And there's a 0 at our top when x equals -2, because our 0 is when that numerator equals 0. So we also know there's no holes, but we don't have x values, right? We said at -5 and at 3. So that's where our verticals are, at -5 and x equals 3. So let's take a look at this next one. So the first thing we're going to do is factor everything. So we have a difference of squares. And then our bottom, if that factors into x minus 3, or x plus 3 and x minus 1. So our domain, again, is all reals, except x, we can't have a 0 in the denominator, so it can't be -3, and x can't be 1. Or, again, you could say -infinity to -3, -3 to 1, and 1 to infinity. So is there a hole here? Well, this reduces out, so there's a hole at -3. And if I plug that in, -3 minus 3, -3 minus 1 is -6 over -4. So there's a hole at -3 and 3 over 2. A 0. So this is where we look in our numerator. So x minus 3 over x minus 1 is the simplified. So there's a 0 at x equals 3. There's a vertical at x equals 1. Horizontal, so that's where we look at our degrees. There's the same, so it's at y equals 1. And our x-intercept, if we plug in 0, it's at 3. And so we can tell this stuff from a graph. So it looks like there's a hole, 1, 2, 3, 4, 5, 6, 7, and 2. Where does it cross the x-axis? At x equals -2 and x equals 2. where does it look like this vertical one is? 1, 2, 3, 4. It doesn't look like there's a horizontal. And there's a y-intercept maybe at negative 0.25. So our domain, it goes from negative infinity to negative 4, negative 4 to our whole, and then our whole to infinity. Or you can say all reals, x can equal negative 4 and x can equal 7. And so this is just a little like sign chart here. So it's asking us, is it positive, negative, or 0? So it's, let's see, from negative infinity to negative 4, it's negative. At negative 4, it does not exist. Negative 4 to negative 2, so right here, it's positive. At negative 2, there's a 0. From negative 2 to positive 2, it's negative. At 2, it's equal to 0. 2 to 7, it's positive. At 7 is our whole, so it does not exist. And 7 to infinity, it is positive. All right, and then you can start on the homework.